Hey everyone, good to be here. Thanks for coming to the conference. Thanks for attending this session. I'm going to be sharing a little bit of insight about what we've learned in the last 18 months of operating OpenSearch at scale at Aiven. But first, I'll give you a little bit of an intro explaining what we do and also how we work with the project. You heard some pretty impressive numbers from Oracle at the keynote. I think this will give you a little bit of a deeper dive into what we see running our service at scale. So I'm going to talk a little bit about what we do, how we work in the community, where we run, and then dig into both some statistics and information about our OpenSearch fleet, and also some incidents, some best practices, some issues that we've run into, just so you can learn about it. We always like learning from retrospectives of incidents and issues that we faced. So sharing a few of those. So we're the trusted open source data platform for everyone. We offer many open source services here at Aiven. And the idea is to make it easy to get started. We provide a lot of capabilities around being cloud agnostic and completely open source based. And I'll dig into that a little bit more. To give you an idea of our portfolio of open source projects, everything we do comes from upstream open source. We do not change the upstream open source. Our secret sauce is really about the platform itself. So how we run across 12 different clouds and how we make the user experience and consistency in managing that type of environment easy. So APIs, Terraform, Kubernetes operator, all of that stuff. I'm obviously going to focus on OpenSearch, but we do a lot of other data streaming and database platforms as a company. And so it's always a challenge as a product leader to figure out what we should build, how we should build it, as well as just operating at the scale that we do as a company. We're headquartered in Finland, but we have people all over the world. Our R&D is generally mostly in Europe. Between Helsinki and Berlin. We're about 500 people trying to, build the best products that we can out there. So I mentioned, and this is a little bit of a preview because we're just actually launching on Oracle, but these are some of the clouds that we run on. We also run infrastructure for many of these cloud providers, data infrastructure. So not only do we sell products directly to companies, but we also allow cloud providers to offer services that they brand as their own that we help them operate. We also have two really differentiated pieces. So in order to run on all of these clouds that we support, we only require some really basic constructs of the cloud provider, namely some level of compute, some level of local storage, an object store, which we use to operate the services, and I'll explain how we do that a little bit more. And then obviously networking, which you need. So we have kind of two deployment models. We have the one where you pay Aiven, we pay the cloud provider bill, we provide you the service. That's the easy way. But if you're a large enterprise, you often have a huge commit deal with, let's say, AWS or Google, where you're spending a lot of money on infrastructure. You want to leverage that deal that you built. So we allow you to bring your own account to us, your own cloud, and we run inside your environment. It also can help with some compliance pieces as well. So it's kind of a unique deployment model. And it's not always one size fits all. We try to provide the things that customers need. And this bring your own cloud thing is pretty compelling for large companies that have big commit spends with cloud providers. So that's kind of a little bit about the models. We obviously started out offering Elasticsearch. And obviously with the license change that everyone went through, we were forced to find a new alternative. And thankfully, our friends at AWS and the community around Elasticsearch, folks that wanted that free service, we all came together and we moved everyone over to OpenSearch. We do not run any Elasticsearch anymore. And I'm going to talk about versions and popularity and things that we see in our environment. It's a little bit unique. So going back to some of the previous conversations that Oracle had today, we actually do slowly change clusters. So let's say you wanted to change the plan that you're running on or change the environment. We do this slowly by replacing nodes and draining nodes and balancing the cluster. We've built a lot of automation to make this seamless and easy. And obviously, we don't want to affect the performance of the cluster when we do that, but we've learned how to do this well. That's a core part of our business, is being able to do this and automate it. We can't use a lot of the tricks that Oracle was talking about, for example, because we have to run on 12 clouds. So we can't, use specialized storage features that are maybe available in one provider, but not in another. So we try to keep it agnostic so that we can operate the service the same way across all the clouds. So we're big fans of open source at Aiven. That's what we believe in. And we don't just believe in that saying we're going to take the free stuff and run it, but we actually contribute significantly. We create a lot of technologies that folks use across the Kafka ecosystem, the Postgres ecosystem, and even in OpenSearch. So I'm going to talk a couple of minutes about the open source program office that we run. We even have one of the folks here, which I'll talk about in a minute, here at the conference, but we have a team of people that only work upstream. I'm the product leader. I try to convince them to build the things that we want in our product, but obviously we also build what's best for the community. So we work together. I have engineering teams that help us build our products, but we also have a separate team that works upstream and is only focused on the success of the open source project. We have maintainers and committers across many different technologies that we use in our platform. This is a subset of the people. Specifically, Andre is here in OpenSearch. He's one of the main contributors to the project. He's done amazing work for the project. Lucas, also on the team, builds the Prometheus exporter that many of you may use in your OpenSearch installations. We certainly use it in ours. And so we believe in really contributing and building these technologies upstream and making it available for the community to make these viable projects. And we do the same thing on Kafka, Flink, Cassandra, and Postgres and other projects as well. So this is a big part of our commitment and what we do as a company to ensure that there are sustainable ecosystems for open source projects. So let's get into the fun stuff, the statistics, what goes on, the technology. Let me jump in a little bit. So I wasn't able to share actual numbers, so a lot of this is going to be relative. We offer basically two main versions of OpenSearch. We have 1.x and we have 2.x. Some customers still want to run on 1, so they're allowed to do that until the project moves to 3, at which point we will start to deprecate 1.x. But for now, we are going to support both. And we support a few current versions of each because customers are kind of slow to upgrade. They want to make sure that they test it. So obviously the newer versions like 2.8, we've seen a lot of adoption. Similarly, 1.3.11 is popular, but we still have people running on older versions. There were some bigger changes on some of these versions, so folks are kind of slow to move over. Since I can't share exact numbers, we're in the thousands of services here. And so that's many thousands of nodes across the services. And I'm going to explain a little bit how we construct plans or the shapes of these clusters and the sizes. So to explain this, this is our standard plans. Because we run on all these clouds, we try to normalize it to say, if you're buying, let's say, the first plan here, Startup 4, that's a single VM, probably for a development environment, with a very small amount of storage and RAM. And then when you get to the larger sizes, like the premium plans, those are large multi-node clusters, and they continue scaling. To go back to what was said earlier today, we also build custom plans for clients. So when someone wants a really large plan, or maybe they want a plan that has less memory and more storage, we can build those custom plans very easily. Our system is completely flexible that way. But a lot of that depends on the cloud provider and what they give us. Sometimes there are limitations on SSD sizes with one provider, while other providers allow you to have very large SSDs that are scalable. So everyone is a little bit different. Next year, we will work on introducing self-service custom plans where you can actually go in, pick an instance type, storage, all of that stuff. But for now, we do that with our customers in concert with them when they have requirements that are outside of our standard plans. The reason I'm explaining this is because I'm going to share information about what plans are most popular and what we've seen. So going back to those pieces, on our OpenSearch side, a lot of the plans tend to be smaller. So think about your team. If you have a few production clusters, you're going to have a lot of development clusters. So we end up with a lot of these small startup clusters, which are not as redundant and not designed for production use. And then, of course, we have quite a few that run in production. They want a business cluster or even a custom plan. So you'll see about 9% of our plans are custom, meaning the customer wants something that's not standard in our plans, but we try to build the plans to be as flexible and fit into what customers need as possible. So it's just kind of an interesting piece that shows how we help companies with development environments and with production systems. So obviously there's a lot of choices in cloud, and the two most popular clouds that we see are AWS and Google. AWS obviously has a great service for OpenSearch. So in our case, we see a lot of folks coming to us that are either multi-cloud, meaning they run on 2 or more clouds, or they want OpenSearch on Google or Microsoft. Those are obviously really popular as well. But we still have a decent amount of implementations on even AWS, as you can see here. So these are some of the popular regions. The company started in Helsinki. So our European business is older than our US business or our Asia business, for example. So as you can see here, really popular regions are in Europe, but we definitely are growing in other areas. We also have better pricing in Europe with Google and some of the other providers. So that also explains if you want something lower cost, we bake in what it costs us into the plan. So that's definitely something to keep in mind. So the other thing we do is we provide really easy integrations. You can click a button and send data to Datadog. You can click a button and scrape it with Prometheus. You can click a button and send your metrics and logs into our Prometheus services like M3DB or InfluxDB, or to OpenSearch for logs. So on the installations that we have in OpenSearch here, you can see that some people don't use an out-of-the-box integration. That's fine. We provide the monitoring and everything else. It's part of the service. However, Datadog's very popular. 26% of our OpenSearch fleet connects to Datadog. We have a native integration. It's definitely popular, especially with enterprise customers. Prometheus, very popular, pretty close to the Datadog numbers, makes it easy for you to scrape those metrics. And then we have other integrations, which you can see kind of down below. The one that says metrics here is our native integration into Prometheus-based data stores. I do want to highlight, which is linked on this slide, is actually a blog on the Thanos site. We are working on a new Prometheus service based on Thanos. which is a really interesting open source project that's part of the CNCF. In this article, we talk about how internally at Aiven, we moved from M3DB, which is a metric system that's Prometheus compatible. You may be familiar with companies like Chronosphere that use it, and how we moved to Thanos and saved a lot of money and really had great performance and outcomes. So that blog is on the Thanos site and is an interesting read for those of you that are interested in metrics, Prometheus, all that fun stuff. So I linked it there, and it's definitely worth a read if you want to see some of the things that we achieved with that work. So now let's talk about incidents. A couple of the names of these things are like internal things that we use to manage our fleet. But I did want you to kind of look at over the past year how we've gotten a little bit better at incident management. Our monitoring has gotten better. We're having less issues that our SRE team really has to look at. So we've been improving. There are less incidents occurring. And obviously, the incident types have changed as the fleet has changed. Our automation has gotten better. We're being more proactive in fixing things. So this is a good trend. We like that. When a service is new, we have a lot of learning to do. As a service matures and gets to the point where now it's getting close to 2 years old, we're much better at operating these things, even though the business is significantly bigger. So I did want to share kind of the overall trend of incidents, and then I'm going to highlight a few interesting incidents that we had to deal with. So this one seems to come up every once in a while. And as we are upgrading to a new version of OpenSearch, we obviously have OpenSearch dashboards and we have OpenSearch. When there's a new version upgrade occurring where we're slowly upgrading that cluster, OpenSearch dashboards actually has a version check on it, and it will start throwing an error if the version doesn't match. Now, this isn't really a problem because most of the time that cross-compatibility works fine. However, this check that's in the code makes it so that it fails. There's a config switch that we've added upstream that allows us to turn off that compatibility check. OpenSearch dashboards is read-only, so it's not really a risk if there's a version upgrade. You may get an error. You may get a 500 error on a certain query if it hits a node that, there's something happening, but in general, it's not an issue. At my last company, we actually removed that flag with like a hard patch to make it work fine as we did upgrades and changes. So this one kind of has caused some customer pain because when we're doing seamless version upgrades, which we do, they don't want downtime on OpenSearch dashboards because a lot of them have embedded that into their products. So this is an issue that we've had a couple times that I hope we've resolved, like finally. But it is one that's come up a few times in the past. So I wanted to call it out here. So if you're doing version upgrades, especially major, like 1.x to 2.x, you may want to enable this flag to make it as available as possible to your customers or users. The second one is a DNS caching issue. So if you're running an older version of OpenSearch, there was a JVM or Java version upgrade that occurred. And as part of that JVM upgrade, the DNS caching behavior changed. And so this caused a few issues with customers of ours that were either doing remote reindexing, or we also support cross-cluster replication and cross-cluster search. And so the DNS caching issue caused things to not work properly. And there's actually a JVM flag that's introduced in newer versions of Java to change the caching behavior. So we had to implement that in our configuration, and this issue was mitigated. But it didn't show up during our testing and in our test suites. But as customers were doing it, it showed up. and this is the fix. So if you are running an older version of OpenSearch or an older JVM and you upgrade, this could be an issue if you're using those features that may have stale DNS issues. So another one to keep in mind, one that we fixed, but was a little bit of pain and a few unhappy customers, so we don't like that. But I'm glad it's resolved. Hopefully you learn from it and don't fall into the same challenge. The other one that's kind of challenging that you may see if you're running across multiple availability zones, which is the default way that we run all of our services, some customers don't always run their services across availability zones in a consistent way. So what ends up happening is that a lot of the cluster pressure is coming in one availability zone, while the other one is generally way less busy. And so what happens is that it's very hard for us to ensure our 99.99% SLA that we provide when the customers are kind of purposefully unbalancing a cluster that should be balanced the right way. And so we've run into issues where heavy bursts of traffic fill up parts of the node, and then the rebalancing kind of just overwhelms the cluster because the data is not flowing the same way. So we added a bunch of AZ-aware logic in the way that we do cluster balancing to make this less of a problem. But this is something that you should think about if you're designing your own clusters. Where is the workload coming from? And where is the cluster running in terms of splitting it across different networks or availability zones? So this one did cause us a couple of incidents. We made changes in our automation, and now it's actually much more AZ aware. The other way to solve something like this is to use some type of load balancer that distributes the traffic. In our case, we would recommend Kafka for that type of thing. Kafka also can provide you with a nice buffer. So one of the discussions earlier today was, how do I deal with problems of my ingestion being overwhelmed? The answer to that is also Kafka, because it creates a buffer. It creates the ability to replay traffic. So we strongly recommend pairing Kafka and OpenSearch if you want something that's really robust. Probably telling people that know that already to do that pattern, but that can also help with this type of availability zone issue and clusters that aren't necessarily balanced the right way. So we use object stores not only for backing up data, but backing up metadata. And when you change plans in Aiven, we actually, in many ways, in many services we actually rebuild the entire environment, restore it from backup, replicate the data to bring it up to date. So we don't believe in trying to reuse nodes or keep things alive. We just destroy and rebuild. That's kind of part of the workflow that we do. And we really need solid object store to work the right way. And in order to do that across 12 different clouds, they have different libraries for their object stores. They have different languages. Although many support S3 compatible storage, not all of them do. And so we sometimes run into bugs. And in this case, there was actually a pretty nasty bug in the Google Object Store client that we were using, where the retry logic was broken. And so what was happening is that our code needed to make up for the fact that their code was crappy and was not retrying reads or writes. And so one of the challenges that we run into is that if it doesn't, sometimes these requests will time out. It's something that you see with object stores regularly, and the client needs to have that logic. So we actually ended up building a wrapper around the client to add a bunch of retry logic that the client should have had that didn't have. So this one caused us some issues on Google. And if you're writing object store, if you're dealing with object stores across cloud providers, this can be a challenge. It certainly is one for us. So it's something to keep an eye on, just adding retry logic. Hopefully, speaking of object store, I will talk a little bit about one of our big requests that many of you are also asking for, but I'll leave that for a moment. So the last one I wanted to share was on disk space and cluster redundancy. So as disks fill up, we notify the customer to take action. Your disk is getting full. You should upsize your plan. You should change your dynamic disk and attach more. So we try to be proactive. We try to reach out to customers, but sometimes they just don't action those things. And we kind of would rather that they don't take an outage because they didn't take action on something. So we are building auto scaling for storage, where we're just going to start adding more storage onto customer nodes and services. The challenge is that their bill's going to go up, which we don't really like to do automatically, but at the same time, it's probably a better outcome than downtime. So that's kind of the plan for us remediating this. It's really challenging because we don't like to charge customers for things unless they're aware of them. We're not your typical cloud provider where the bill is complicated and difficult to interpret, or there's all these weird charges on it that I'm sure you've all seen. But in this case, I think we have to make the right call, which is to keep the customer online, even if it does increase some of their storage costs. So this is something that'll be out before the end of the year, auto scaling, and we'll just kind of have to see what customers think of that. But that's our plan to avoid these disk space issues and cluster issues that we sometimes run into. So I do want to share a little bit as I wrap up. Like most of you, we're really interested in tiered storage in OpenSearch, fully writable tiered storage. This is a big ask for customers who want lower cost services and want to keep data for longer. We have tiered storage support in our Kafka, in our ClickHouse service, and we're looking to get that in OpenSearch. We've obviously been trying to contribute to make that happen. So we're super excited to see that happen in the project when it does get done. It's really important. It's our #1 ask from customers on OpenSearch. So I did want to mention a couple of interesting pieces here, just to finalize things. We recently moved from our own permissioning model to the security plugin. There's an interesting blog about that migration. I know it came up in one of the earlier talks today. We did it seamlessly and gave customers a lot more flexibility using the security plugin, but it was a big project to try to do that without breaking anything. So it's kind of interesting to read about that for those of you that are maybe trying to adopt the security plugin or change to using that. The other thing is we keep our roadmap completely public, and we open up for suggestions or contributions from anyone, customer or not. We have free services available for a lot of our services like Postgres, MySQL, and Redis. There's even free plans that people can use. But the roadmap is cool. You can see what we're working on and what we're doing. So definitely have a look. It's easy to contribute to that and see what we're up to. So did want to share that. And just wanted to thank everyone and thank Aiven for also sponsoring the conference. And I know we're short on time, but I will be outside and happy to take questions or if you see me around. And thanks for listening. Appreciate it.